Hello students, welcome to Anne's classes. Let's do exponents. Chapter 2, Test Yourself. Test Yourself, page 39. Question 2. Evaluate. In that first one is minus 3 by 5, the whole raised to the power of 3. So this will be equal to minus 3 raised to the power of 3 by 5 raised to the power of 3. Now here we know when you have a minus sign and our power is an odd number, your answer will always have a minus sign. So that is minus. Now 3 raised to the power of 3. That is 3 into 3 into 3. 3 3s are 9, 9 3s are 27. So this is 27. And in the denominator, we have 5 raised to the power of 3, which is 5 into 5 into 5. 5 5s are 25, 25 5s are 125. So here we have 125. So what is our answer? Minus 27 by 125. Question 2. 2 by 7 raised to the negative power minus 2. So we're going to make the power positive by writing the reciprocal of this. So 2 by 7 will now become 7 by 2 and this is now raised to a positive power, that is 2. So this becomes 7 raised to the power of 2 by 2 raised to the power of 2. 7 raised to the power of 2 means 7 sevens are 49 and 2 raised to the power 2 2s are 4. So what is our answer? 49 by 4. Question 3, evaluate. So here under this, the first question says minus 2 by 5, the whole thing raised to the power of 4 into minus 5 by 2, the whole thing raised to the power of 2. Now, if we have to use the law of exponents, only if the base is the same and it is multiplication, we can add the powers. Here the base is not the same. But look carefully. Here we have 2 by 5 and here we have 5 by 2. So one of these we can change so that the base is the same. So here in this case, I'm going to leave this as it is, but I'm going to change this. So let's see how to do that. So first we begin by writing the same thing, the first rational number minus 2 by 5, the whole thing raised to the power of 4 and this is multiplied by, now what we're going to do is, we're going to write the reciprocal of minus 5 by 2. It will become minus 2 by 5. Then what happens to the power? Power is positive. When you write the reciprocal of this, that will become negative. So now let's do that. So we're going to write minus 2 by 5. Now remember the power will change, 2 will become minus 2. Now why did we do the reciprocal of this? So that the base can be the same. Now can you see that the base is the same, it's multiplication, use the law of exponents, according to that you can add the powers. So when base is the same, you can add the powers for multiplication. So 2 by 5 raised to the power of, let's add up the powers, 4 plus minus 2. So this becomes minus 2 by 5. Now let's add up the powers. So that is 4 minus 2. So minus 2 by 5 raised to the power of 2. So this will be minus 2 raised to the power of 2 by 5 raised to the power of 2. So that is minus 2 into minus 2. Minus into minus is plus, 2 2s are 4. So plus 4, or you simply can write 4. 5 square means 5 into 5, which is 25. So this is 4 by 25. So this is our answer here, 4 by 25. Question 2, evaluate again. So here it is minus 3 by 7, the whole raised to a negative power into 7 by 3 raised to 2, the power of 2. Now here minus 3 by 7, since it's raised to a negative power, we can make it a positive power by writing the reciprocal of this. So what does this become? This becomes minus 7 by 3 raised to the power of 5 into 7 by 3 raised to the power of 2. Now here as you can see, this is minus 7 by 3, whereas this is 7 by 3. Now this one, to make it positive like this, we have to remove the minus sign, isn't it? So what can we do? We can write it this way. We can say Minus 1, we can write it as minus 1 into 7 by 3, the whole thing raised to the power of 5 into, this remains the same, 7 by 3 raised to the power of 2. So this can be written as minus 1 raised to the power of 5 into 7 by 3 raised to the power of 5. And the other one is 7 by 3 raised to the power of 2. Now, when you have a minus sign and you have an odd number as the power, your answer remains negative. So minus 1 raised to the power of 5, you multiply it 5 times, you still get minus 1 into. Now here what we can do is we can add up the powers because now the base is the same. So let's write 7 by 3 raised to the power of 5 plus 2. So this becomes minus 1 into 7 by 3 raised to the power of 5 plus 2, which is 7. So minus 1 into this becomes minus 7 by 3. Minus 7 by 3 raised to the power of 7. Or you can also write it as minus in the middle. Okay, minus 7 by 3 raised to the power of 7. This is our answer. Question 4. Evaluate. Here we have minus 1 by 2 raised to the power of minus 2, and that whole thing is raised to the power of minus 3. First, let's work on the powers. So here you can use a law of exponents and multiply the powers. So minus 2 into minus 3 you can multiply. That becomes plus 6. So what do we have here? In this step we have minus 1 by 2. Now this one is raised to the power of 2 into 3, that is 6. Minus into minus is plus. So minus, it's raised to the power of 6. Minus 1 by 2 is raised to the power of 6. Now, we also know that if you have a negative number and it's raised to a power that is even, your answer is going to be positive. So, in your answer, you don't have to write minus. Now, the numerator has to be multiplied 6 times. So, that means this is going to be 1 raised to the power of 6 by 2 raised to the power of 6. 1 raised to the power of 6 will be 1. Now, 2 raised to the power of 6, you multiply 2 6 times. 1, 2, 3, 4, 5 and 6. 2 twos are 4, 4 twos are 8, 8 twos are 16, 16 twos are 32 and 32 twos are 64. So here we have 64. So what is our final answer? 1 by 64. Question 2. Now here we have minus 1 by 5, which is raised to the power of 2. Now that is raised to the power of minus 2 and that whole thing is raised to the power of minus 1. So first thing we have to do is multiply the powers. Let's multiply these two powers first. So that is minus 2 into minus 1. So we know minus into minus is plus, 2 ones are 2. So that becomes 2. So let's write this. This is now minus 1 by 5, which is raised to the power of 2, which is now raised to the power of plus 2 or simply 2. We worked that out and we got 2. Now we have to work on these two powers. 2 2s are 4. So what will we have here? We'll have minus 1 by 5. Now this whole thing is now raised to the power of 4. 2 2s are 4. Then again, have a look at the sign. This is a minus sign and the power is an even number. That means your answer is going to be positive, no minus sign. So this is going to be simply 1 raised to the power of 4 divided by 5 raised to the power of 4. 1 raised to any power will be 1 and 5 raised to the power of 4 will be 5 into 5 into 5 into 5, 4 times. 5 5s are 25, 25 into 5 is 125, 125 into 5 is 625. So here we write 625 and what is our answer? 1 by 625. Question 5, evaluate. In that the first one. 7 raised to the power of minus 1 minus 8 raised to the power of minus 1 minus 3 raised to the power of minus 1 minus 4 raised to the power of minus 1, and this whole thing is raised to the power of minus 1. So let's go slowly with this and do it carefully without making mistakes. So here in brackets we have 7 raised to the power of minus 1. Let's make the power positive. So 7 becomes 1 by 7 raised to the power of 1, which is 7 itself, minus 8 raised to the power of minus 1, write the reciprocal, 1 by 8 to the power of 1, which is again the same thing, so I'm not writing that 1, minus, here let's write 3 raised to the power of minus 1 is 1 by 3 minus 4 raised to the power of minus 1 is 1 by 4. And this whole thing is raised to the power of minus 1. Now we have to work out this first and then we'll work out this. So here when we work out this, what do we get? Here we have to find the LCM of the denominators 7 and 8. And the LCM is 7 into 8, which is 56. Now let's look at the first denominator 7. 7 you have to multiply it by 8. So you multiply 1 also by 8. So here we get 8 minus, here it is 8 into 7 is 56. So multiply this also by 7. 1 7s are 7. So we have finished this side. Now on the other side we have minus. Now here what do we have? Now 1 by 3 minus 1 by 4. Must find the LCM of 3 and 4 and that is 12. So the LCM is 12. So the first rational number 1 by 3, denominators 3, 3 4s are 12. So multiply 1 into 4. 1 4s are 4 minus the next one is 4 3s are 12 and this is 1 into 3, 1 3s are 3. And this whole thing is now raised to the power of minus 1. Keep that there. Now this is 8 minus 7 is 1, 1 by 56 minus 4 minus 3 is 1, 1 by 12 and this is raised to a negative power. Now we are going to change the negative power to a positive power. Now how do we do that? This first one we are writing as it is. 1 by 12 we make it the reciprocal which is 12 by 1 and now the power is positive 1. So this is 1 by 56 minus 12 by 1. Now we have to find the LCM of 56 and 1 which is 56. So the first one is 56 into 1. So this is 1 into 1 which is 1 minus, take the next one, 1 into 56 is 56. That means we have to multiply 12 into 56. 12 into 56 is 672. So what do we have now here? 1 minus 672. 672 has a negative sign. That's a bigger number. So we put the sign of the bigger number and we subtract. 672 minus 1 is 671 and the denominator is 56. So what is our answer? Minus 671 by 56. Question 2. Here we have 5 to the power of minus 7 divided by 5 to the power of minus 10 into 5 to the power of minus 5. So division and multiplication are there. According to Bodmer's, we should do division first. So since the base is the same, we can subtract the powers. So this is 5 to the power of minus 7 minus 10. Okay, I hope you understood. Since this is division and the base is the same, we can subtract the powers. So I did minus 7 minus 10 and the rest remains the same into 5 to the power of minus 5. So this becomes 5 to the power of minus 7 and here minus into minus is plus. So that is plus 10 into 5 to the power of minus 5. So this is 5 to the power of, here signs are different. We put the sign of the bigger number which is plus and subtract. 10 minus 7 is 3. That's plus 3 or simply 3 into 5 to the power of minus 5. Now can you see the base has become the same. That means we can add up the powers. So here what do we have? 5 to the power of 3 plus minus 5. I'm adding up the powers only. So 5 to the power of 3 minus 5, which is 5 to the power of, signs are different, put the sign of bigger number and subtract. 5 minus 3 is 2. So now we have 5 raised to a negative power. We can make this positive by writing the reciprocal of 5. 5 is 5 by 1. The reciprocal will be 1 by 5 and this is raised to the power of 2. So this is 1 into 1 which is 1 and 5 into 5 which is 25. So what is our final answer? 1 by 25. Question 6. By what number should minus 5 raised to the power of minus 1 be divided to give the quotient minus 25 raised to the power of minus 1? So that means minus 5 raised to the power of minus 1 should be divided by a number. So let's consider that number to be x, and the quotient will be, which is already given to us, minus 25 raised to the power of minus 1. Now let's work on this side first. So here we have minus 1 raised to the power of minus 5 raised to the power of minus 1. Let's make this a positive power by writing the reciprocal. So this becomes 1 by minus 5. Okay, and this is division divided by x, which is equal to, here also let's write the reciprocal. So minus 25 becomes 1 by minus 25. Now the power is positive 1. Okay, now here 1 by minus 5, let's change this division to multiplication. So this becomes multiplication. That means we write the reciprocal of x by 1, which becomes 1 by x, and this is equal to 1 by minus 25. So here we can multiply the numerators and the denominators. 1 into 1 is 1, minus 5 into x is minus 5x. And this is equal to 1 by minus 25. So here when you have something like this, you can cross multiply. That means I can multiply 1 and minus 25, the numerator and denominator. So what will that be? 1 into minus 25 is minus 25. And this will be equal to multiply the other side, minus 5x into 1, which is minus 5x. Now let's find the value of minus 5x. Minus 5x is equal to minus 25. Therefore, x will be equal to minus 25 divided by minus 5. Why division? Because here it's multiplication. So when it goes to the other side, it becomes division. So here the minus signs will get cancelled. 5 fives are 25. That means x is equal to 5. So we've got our answer. X is equal to 5. Find n so that 8 raised to the power of 11 divided by 8 raised to the power of 5 is equal to 8 raised to the power of minus 3 into 8 raised to the power of 2n minus 1. So first let's take this part. As you can see, the base is the same, isn't it? And in case the base is the same and it's division, you can subtract the powers. So this will now become 8 raised to the power of 11 minus 5. We can subtract the powers. Now on this side it is multiplication. That means we can add the powers. So 8 raised to the power of minus 3 plus 2n minus 1. So this is now 8 raised to the power of 11 minus 5 is 6. And here we have 8 raised to the power of minus 3 plus, let's open the brackets, 2n minus 1. So here we have 8 raised to the power of 6, and here we have 8 raised to the power of, now here we have 2n, let's write 2n first, and then we have these whole numbers minus 3 minus 1. That is, signs are the same, put the same sign and add 3 plus 1 is 4. So now we know that when the base is the same, the powers are equal. So let's take only the powers now. So here it is 6 is equal to 2n minus 4. Or I'll change the sides and say 2n minus 4 is equal to 6. Now we're going to find the value of only 2n. 2n is equal to 6 plus 4. Because we're transposing minus 4 to the other side, it becomes plus 4. So here 2n is so much. 2n is equal to 6 plus 4 is 10. Now we can find the value of n. n is equal to 10 divided by 2, or n is equal to 10 divided by 2 is 5. So we have found our answer. The value of n is 5. Question 8. Find n so that 9 raised to the power of n plus 2 is equal to 240 plus 9 raised to the power of n. Now look carefully. I'm going to write this as it is. This is an equation. So I'm going to write 9 raised to the power of n plus 2 as it is. And what I'm going to do is I'm going to move this 9 raised to the power of n from the right hand side to the left hand side. Because it is plus, now it's going to become minus 9 raised to the power of n. So, and this is now equal to 240. Now listen carefully, children. Now this part, 9 raised to the power of n plus 2, I'm going to write it as 9 raised to the power of n into 9 raised to the power of 2. How did I get that? Now we know the law of exponents. When the base is the same and it is multiplication, we can add up the powers. So here that is what is done. Now this part I have reversed and written it like this. So this part has been written like this. Now I'm going to write minus 9 raised to the power of n, minus 9 raised to the power of n, and here it is 240. Now I'm going to look at this part alone and this part, and we have a minus sign in between. What is common? What is common to this part and this part? As you can see, here we have 9 raised to the power of n. Here also we have 9 raised to the power of n. So what I'm going to do is I'm going to write 9 raised to the power of n separately, and in brackets I'm going to write the rest. So here I have 9 raised to the power of 2, which I'm going to write here. So 9 raised to the power of 2. And here I already have 9 raised to the power of n, which is there outside. So instead of writing this again, I'm going to simply write 1. Why? Because if I say 9 raised to the power of n into 1 is 9 raised to the power of n. So that is 1. And here we have 240. Now this is 9 raised to the power of n into 9 nines are 81 minus 1, which is 240. So now again we have 9 raised to the power of n into 81 minus 1 is 80. This is equal to 240. Now we are going to find the value of n, isn't it? So we are going to write 9 raised to the power of n is equal to 240, and this 80 which is on the left hand side, I'm going to take it to the other side. So this is multiplication, so when it goes to the other side it becomes division by 80. Now I can cancel first the zeros. Now I can cancel 24 and 8. 8 threes are 24. So now what do I have? I have 9 raised to the power of n is equal to 3. Isn't it? 9 raised to the power of n is equal to 3. Now here we'll try and make the base the same. So here we already have 3 and here we have 9. We can write 9 as 3 to the power of 2. Isn't it? 3 threes are 9. This is 9 and this is raised to the power of n. Whereas on this side we can say 3 is raised to the power of 1. So now how can we write this? We can say 3 is raised to the power of 2 into n, because you can multiply the powers. This is equal to 3 raised to the power of 1. And now we know that when the base is the same, the powers are also equal. So I'm going to take only the powers now. That is 2n is equal to 1. That means if I have to find the value of n, I say n is equal to 1 by 2, because I have transposed this 2, which is multiplication, to the other side. It has become division. So now I have found the value of n. N is equal to 1 by 2. Question 9. Find x if 3 raised to the power of 2x minus 1 is equal to 27, x raised to the power of x minus 3. So here what we are going to do is we are going to write this first one as it is, 3 raised to the power of 2x minus 1, and here 27. Let's find the prime factors of 27. 3 nines are 27, then we have 3 threes are 9, and then we have 3 ones are 3. So now we can write 27 as 3 raised to the power of 3, isn't it? So here let's write 3 raised to the power of 3, which is 27, and 27 is raised to the power of x minus 3. So here on this side we have 3 raised to the power of 2x minus 1, and here we have 3 raised to the power of, now we have to multiply 3 into x minus 3. So let's do that. 3 into x minus 3 when we multiply. First we multiply these two. So 3 into x is 3x minus 3 into 3. 3 threes are 9. So here we get 3 raised to the power of 3x minus 9. So now the base is the same. That means the powers are equal. So we can write that. We can say 2x minus 1 is equal to 3x minus 9. So now we can bring all the x to one side. So let's have 2x here, and we're going to bring this 3x to the side. So here it is plus, it becomes minus. So that's minus 3x. And on the right hand side we have minus 9, and we're going to move this minus 1 to the other side. It becomes plus 1. Now let's work this out. 2x minus 3x, signs are different. put the sign of the bigger number and subtract. So that is minus 3 minus 2 is 1, minus 1x is equal to, here also signs are different, put the sign of the bigger number and subtract. 9 minus 1 is 8. So now we know that minus 1x is equal to minus 8. Let's find the value of x. This is minus 8 divided by minus 1, because here we have transposed this minus 1 to the other side. So it has become plus. Now let's cancel. And 8 by 1 is equal to 8. So we have found the value of 8 of x. X is equal to 8. This is our answer. Question 9. Find x if. Now look at this whole equation carefully. Now here there are some numbers which are not prime numbers like 25, 125, 625. They are not prime numbers. So what we can do here is find the prime factors of these numbers. So let's begin with the first number, which is 25. So what are the prime factors of 25? 25 you divide it by 5. 5 fives are 25. Divide again by 5. 5 ones are 5. So 25 can be written as 5 raised to the power of 2, isn't it? 5 into 5. So let's write that. So 5 raised to the power of 2 is 25, and that whole thing is raised to the power of x, as you can see. Into the next one is already in the form of a prime number, 5 raised to the power of 5, into, now we have 125 raised to the power of 3. So 125, let's find the prime factors, starting with 5. 5 twos are 10, so 10 is over, there's 2 left. 25, 5 fives are 25, continue. 5 fives are 25, continue again. 5 ones are 5. So here 125 can be written as 5 into 5 into 5, which is 5 raised to the power of 3. So here let's write that. So this is 5 raised to the power of 3, which is 125, and that is already raised to the power of 3. Now in the denominator we have 5 into, now 625. Let's find the prime factors of 625. Divide this by 5. 5 ones are 5. What is left is 1. 12. 5 twos are 10. What is left is 2. 5 fives are 25. Continue. Now this is 5 twos are 10. There's 2 left. 5 fives are 25. Continue. 5 fives are 25 and 5 ones are 5. So 625, the prime factors are 5 into 5 into 5 into 5. That means 5 raised to the power of 4. So here we can say 5 raised to the power of 4 is 625, and that is raised to the power of 4. So what you've done is this 625 is 5 raised to the power of 4, and that is raised to the power of 4 again. And all this is equal to 125. So that we'll write it as it is now, 125. So now here we have 5 raised to the power of 2, which is raised to the power of x. We can multiply the powers using the law of exponents. So let's do that part. So now this becomes 5 raised to the power of 2x into 5 raised to the power of 5 into 5 raised to the power of, here also we could say 3 3s are 9. Multiply the powers. So we have 5 raised to the power of 9, and in the denominator we have 5 into 5 raised to the power of, here we have 4 into 4, which is 16. 5 raised to the power of 16, and all this is equal to 125. Now we know when the base is the same, we can add up the powers, isn't it? So here the base is the same and it is multiplication, so add up all the powers. So this becomes 5 raised to the power of 2x plus 5 plus 9. And in the denominator also we have 5 raised to the power of 1. That's 1, isn't it? Plus 16. All this is equal to 125. So now let's continue. 5 raised to the power of, now 2x plus 5 plus 9. 2x cannot be added with 5 and 9. So this will be 2x plus 5 plus 9. 5 plus 9 is 14. And in the denominator we have 5 raised to the power of 17. So all this is equal to 125. Now here the base is the same. That means you can subtract the powers, isn't it? So here what will this be? This will be 5 raised to the power of 2x plus 14 minus 17, which is 125. Now let's simplify this. 2x will remain the same. We can do 4 plus 14 minus 17. Signs are different, so put the sign of the bigger number and subtract. That is 17 minus 14, which is 3 minus 3. So this is now going to become, I'll write it here, this is now going to become 5 raised to the power of 2x minus 3 is equal to, now instead of 125, we are going to write 5 raised to the power of 3 as we got it here, 5 raised to the power of 3. So now when the base is the same, the powers are equal. So 2x minus 3 and 3, they're equal. So we're going to write that 2x minus 3 is equal to 3. The powers, we've written only the powers. Now we're going to find the value of only 2x. 2x is equal to 3. Now we are going to transpose this minus 3 to the other side. It's going to become plus 3. So 3 plus 3. So 2x is equal to 3 plus 3 is 6. Therefore, x is equal to 6 divided by 2. That means x is equal to 6 divided by 2 is how much? 2 3's are 6. So x is equal to 3. So we have found our answer here. We are asked to find the value of x and we have found the value of x to be 3. So this was the last question in Test Yourself, question 9, the second one. With this, we have come to the end of Test Yourself for Powers and Exponents. Thank you, children.